Hey, I'm Rosie Machenzo and I'm going to brought up the topic estimating the probability of completion dates. But before we move on to this topic, we will have a short recap about probabilistic time estimate, which is going to be used later on this topic. Probabilistic time estimate. What is a probabilistic time estimate? It has three time estimate, which are the optimistic time estimate, the most probable, and most likely, and the last is pessimistic time estimate. This three estimate denotes as over optimistic as time estimate, which is the shortest time and most reasonable for the most likely. P for pessimistic time estimate, which is the longest time estimate. Your time estimate is needed to compute the expected time for each activity, which has the formula expected time is equal to optimistic time plus 4m plus pessimistic time all over 6. The expected activity time, the next step is to transfer it to the network diagram. Now, it is the time to determine the critical path. In getting the critical path, there are two ways. First is the more practical one. You have to calculate the expected time each path through network. Here is the network diagram. For the path 1, we have A, B, D, E, G, I, J, and K. For the second path, or the path 2, we have A, B, D, E, G, I, J, K. For the path 3, we have A, C, F, G, I, J, K. And the last path, or the path 4 is A, C, F, G, I, J, K.
Go.
The critical path is the longest path through the network. Therefore, the second path, which is A, B, D, E, G, I, J, K, is the critical path, and it will determine the expected completion time for the project. The method for determining the completion project time date is using the probabilistic time estimate. Probability of completion dates. An advantage of using probabilistic is that you'll have the ability to predict the probability of project completion dates. We had learned to calculate the completion date by the three-time estimate. Now, we are going to calculate for the variance of beta probability distribution. For getting the variance is equal to P minus O all over 6 squared. Getting all the variance that is presented in this chart, we'll need to calculate the variance for path through network. In getting the variance for path through network, it is the same process as we did in getting the expected completion time. We just add or sum up all the activities on the path through network to get the completion dates and the variance. Now it is time to determine the probability of a specific completion date. We will use 48 weeks as the specified time. Formula in getting or determining the probability of specific completion date is equal to a specified time minus path expected completion all over path standard deviation.
Alright, now in this video and the next couple of videos we are looking at PERT problems for project management for building schedules and network diagrams. So you'll see here we have our table of dependencies with some familiar information. We have our activity, we have the predecessors, but normally we would have the activity duration. But here instead we're seeing TA, TM, and TB. So what these are, TA is our most optimistic duration, TM is our most probable duration, and TB is our most pessimistic duration, which we can use these, there's a formula that we can use to get the mean, which is our expected duration, and then also the variance and the standard deviation for each activity. So here are the formulas for the mean, variance, and standard deviation. So for expected duration, which is also the mean, we would have the formula being TA plus 4TM plus TB all over 6. So for the case for activity A, we would have 2, which is TA, plus 4 times TM, so 4 times 4. So here we can even do this in the case of activity A. Mean is TA, so we had 2 plus 4 times TM, so plus 4 times 4 plus TB, which is 9. And that is all divided by 6. So if you just punch that in your calculator, you'll get the mean is 4.5. This is our expected duration. So knowing that our most probable, based on our experience or someone's given this most probable duration was 4, the most optimistic was 2, and the most pessimistic was 9. For the purposes of PERT, our expected duration with this formula will be 4.5, and we're just assuming this is days or minutes or whatever the unit is given to you. For these problems, it'll usually be in days. All right, then so for variance, we would have, again, we can just apply this for activity A. We would have variance is equal to TB minus TA. So we would have 9 minus 2, there we go, all divided by 6. And then you want to square that whole thing. And if you do that, if you punch it in your calculator, you will find that we are going to get a variance of 1.36. Now, you will need this variance for later problems to do with PERT, so just keep it around for now. You always want to calculate that. So we have 1.36. And then standard deviation, literally just take the square root of that, and you will get a value of 1.17. There you go. All right, so we would put that in for activity A. So what you can do then is you can use these formulas and you can find out the expected duration of each activity, the variance, and the standard deviation, and so they are all down here as follows. So there you go. I encourage you to try out some of these yourself using these equations, and I will see you in the next video, and we will start drawing network diagrams for PERT problems.